I'm a senior software architect at Cetaris, so right now, I've built applications on .NET. It's kind of my background. WinForms, XAML, C#, like all that type of stuff now. And enterprises are starting to experience the creep of we got to have a mobile app. It's got to run everywhere, but we don't have any money to do it. So so we're settling on the web. It's probably as future-proof as you can get. Nick touched on a lot of great points. So Nick, you're right about everything. We landed on Angular after a number of different kind of exploration projects and prototyping work that we did, and we're comfortable now that that's the right decision moving forward. So we've layered a few things on top of it. One of them is TypeScript. And the reason we did that is because building big JavaScript applications is hard. So it's hard for kind of a number of reasons, and depending on your background, this is a bit of a religious debate whether you're kind of a functional programmer, you love your dynamic languages, or you're maybe in an enterprise where you're coming from a statically typed language like Java or C#, right? So there's all different ways of building applications. For us, we're kind of the statically typed fans. We like what it does for us, and I'll talk a bit about that. But TypeScript is one of the things that we're adopting because it gives us some of the, solves some of the challenges that we have around structuring our code. So structuring it with classes, with modules, interfaces, the type of stuff that a dynamic language just can't really help you out with. So. All right, so what is TypeScript? So it's a language for large-scale application development, and that's the marketing speak. And the reality is that it's a typed superset of JavaScript that compiles down to plain old JavaScript. So in the end, what you get, what you ship, is JavaScript. You minify it, it's a JavaScript application. This just sits on top of it, and it gives you a lot of the design time IntelliSense and language capabilities of having a statically typed language. Yes?
I thought the primary emphasis was that it was object-oriented and the typing is optional.
The typing, yes, exactly. Yeah. Yep. The typing is optional. So, I'll walk through this and I'll show you guys kind of as we go, kind of how you can incorporate it. You can kind of go, just kind of dip your toe in the water, or you can kind of go all the way, right? So we'll talk about all of that type of stuff. So, it does add things to the JavaScript language, many of them which align with ECMAScript 6. So things like classes, lambdas, a whole bunch of features that are coming down the pipe, and it allows you to use them today. So if you like classes and you want to write your code using classes, there's different ways of doing this, obviously. You can incorporate frameworks to do this, like Prototype or whatever. That add that to JavaScript, or you can, it's still kind of sitting on top of a dynamic language. There's no compiler there or anything. It's just giving you some functionality to make it easier to simulate classes and things like that. So what TypeScript is actually a compiler. It is compiling the code that you write in TypeScript, which is really just a superset of JavaScript. Anybody done CoffeeScript here? Okay, so CoffeeScript compiles down to JavaScript, right? And do you like it? CoffeeScript. Okay. So, well, why do you like it? Is it productivity?
It's a lot like Ruby.
It's a lot like Ruby, right? So because it's not JavaScript.
When you're building tests, it's a lot smaller.
Right. Yeah. So it's like less code effectively that you're writing, right? Yeah. So TypeScript, you can think of it like CoffeeScript, except you don't have to mentally do the mapping between what is JavaScript really outputting. A lot of the time, if you're a CoffeeScript guy, you're probably not even thinking about what it outputs. But with TypeScript, you're still thinking about JavaScript as you're writing it. So. I figured out what the sweet spot. It's getting closer. I think the battery is. I'll be at the back of the room soon. Any help back there? Oh. All right. It's open source. So this is an open source technology. It was created by Microsoft. So, booze? Okay. Well, the main guy behind this is actually Anders Heilsberg, and you might know him from such frameworks as Turbo Pascal, J++, Microsoft Foundation classes, and C#. So there's a little bit of experience in the compiler building world behind this project. It's all the software is open source. The development is being done in the open, and it's on GitHub. And they are taking pull requests. So I've personally found that the team is being very responsive to suggestions and problems and stuff that exist in the language. What do I like about it? Well, I like that it's not that far away from JavaScript. CoffeeScript for me is a little bit too far away from what it's outputting. I mentioned before, it adds classes, modules, interfaces. Java developers, C# developers here? You like generics? All right, you can have generics in TypeScript, so that's pretty cool. I'll show you that. Lambdas, optional static typing. So you don't have to use it. TypeScript is JavaScript. You can just copy and paste it, and it works. And it works, this is a cool thing, it works with all existing frameworks. So Angular, Backbone, Knockout, pick your framework, it will work with that just fine. And actually really enhances the development experience as you're using these frameworks. And because it's adding these things on top of the language that may not be in the version of JavaScript that you're using in the supported browsers that you're targeting, it has to compile these language constructs down to regular JavaScript. And it does that by trying to generate idiomatic JavaScript. So that's the JavaScript that you would have to write today to simulate classes, to simulate modules and namespacing and all of that type of stuff. And that's good, right? So, because that guy says it is. So let's go next. So he's got a book, Douglas Crockford, called JavaScript, The Good Parts. And there's a lot of good reading in there if you're thinking about transitioning your skill set over into Angular, TypeScript. That's a really good starting point. The other book is the JavaScript Patterns. So. This is a list of what TypeScript adds on top of JavaScript. Many of these things align with ECMAScript 6. So we're going to go through a number of these. We just don't have time tonight to kind of do everything, but try to get through as much as we can. What we've experienced at Cetaris using this, and we've used it with other frameworks, not just Angular. So, I'm sure everyone here is not Angular. They're just maybe here keeping an eye on what's going on. Maybe you've got another framework that's your favorite that you're using. Well, you can use TypeScript with that too. So there's a lot of benefits to that. We've noticed a huge reduction in code defects, and I'll show you why. One of the big reasons is that TypeScript acts as our compiler, which is really our first set of unit tests, right? Does the thing compile? That's in a statically typed language, that's your first unit test that you didn't have to write, which is usually the only one that most people write. So I find that for new developers that might be transitioning to JavaScript from C#, it's a lot faster because it feels more like C#, it feels more like Java as well, because of the static types and the assistance that it can give because of things like the IntelliSense or code completion that it enables. You spend a lot less time sitting at your computer with 10 browser tabs open and all the frameworks you've cobbled together to build your app because you have really good IntelliSense from these frameworks. Definitely, there's some integration friction, so we've experienced this. The language, we've been using it for a while now, and the language, as it's evolved, has changed. The quality of some of the statically typed definition files for these third-party languages like Angular and things has varied over time. It's at a pretty good point right now where I'm comfortable using it. It's at 1.0. And a lot of the community has really kind of grown up around TypeScript. It also helps you kind of create easier to maintain, cleaner code, and eliminates the dangerous find and replace code refactoring that you end up doing in JavaScript, right? So, because that's really all you can do, because the tooling can't really help you refactor the code. Here's some apps that have been built with it. Obviously, a lot of them are Microsoft, some of them are not.
You actually skipped a slide.
Did I?
Yeah.
Probably wasn't important. I don't know how to
it was
go back.
IDEs.
Oh yes, IDEs. It is important. So this is not just a Microsoft thing. They built it, but it's open source. Other IDEs have incorporated this into their editors, and this is the list basically. There's build tools that support this too. TypeScript comes with a command line compiler, tsc.exe, which you can run from whatever batch file or bash file you want. So there's Grunt and Gulp integration. So if if that's your build stack, then you can just set up watches and have it automatically compile your TypeScript files as it changes. So you're probably already doing that with code minification and stuff like that today. All right. There we go. There's his head. So a couple apps here. One I wanted to point out was Visual Studio Online, because it's a pretty impressive application if you've ever kind of gone in and tinkered with it. And they've done two big projects there, which is the Team Foundation Service Online, which is their online ALM tooling. It's all written in TypeScript. There's 150,000 lines of TypeScript in that application, or JavaScript, whatever you want to call it. They've also built an online editor called Monaco, which is like an IDE in the cloud, similar to Cloud9. And so there's a couple of applications there. So people are using it. All right, so I'm going to try to do some demo here and see how this goes. I have to set up my mic stand. Unfortunately, if I drink the beer, it falls over. So poor design. All right. Can you guys hear me okay still? All right.
This is actually a re-recording of the demo that I gave at the AngularJS Toronto group. We had a little bit of technical difficulties and we lost the recording. So I'm just going to redo the demos that I gave, and we'll probably be missing a few questions from the audience, but for the most part, this is exactly the same presentation. Okay, so we are now in the Visual Studio IDE. This is Visual Studio 2013. As I mentioned before, you can use whatever editor you like. There's a number of editors that support TypeScript natively or through the addition of plugins. And what we're looking at right now is an app.js file. This is just, I'm going to paste some code in here, some just regular JavaScript code. And I'm going to save that. And to kind of show you one way of starting with TypeScript, since TypeScript is a superset of JavaScript, any JavaScript file can effectively be converted to a JavaScript file just by renaming it. So I just close that file there. I'm just going to go over here. I am going to rename that to a TypeScript file. So with instead of JS, a TS extension. Just reopen that. And so now what you see is something a little bit different. Now Visual Studio has a preview window which is going to show you on the left hand side over here, it's going to show you the TypeScript that you're writing. Obviously nothing's changed, this is still the same JavaScript that I pasted before. On the right hand side, when I save the file, it's going to compile the TypeScript on the left into JavaScript and show me what that looks like. So if I save that now, I can see here that there's zero difference. Maybe there's a little bit of white space formatting differences, but that's it. It's exactly the same code on the right as it is on the left. It's just valid JavaScript. Let's take a look at this method here called sortit, and let's try to run this. The code here, it looks like this function takes some value. In this case, I can look at the code and I can see it's taking some type of string. So I suspect this is probably going to slice this string and it's going to sort it. And then it's going to write it out to the document. So let's just run this and let's see what it outputs here. Okay. So now Visual Studio is telling me that there's some type of problem here, and it's that some object doesn't support a property or method let's see here, property or method sort. Okay, so I've probably got some bug in my JavaScript. And if I break into the code here, I can go and I can look at this. I can see, oh, sort is undefined and result is a string. And so obviously I've passed in a wrong value here. I can kind of tell that this function was not expecting to receive just a string. It looks like it was expecting to receive an array, and it was going to slice that array and then do some sorting on that array. Now, that's not completely obvious from looking at this code, and if I was a third-party developer or somebody new to the code base and I was trying to look at the sorted function simply from the signature of this, I may not necessarily know what I was supposed to pass into that. I might end up passing the wrong thing, and then at runtime, if I don't have any tests written around this, which we know that happens sometimes, I'm not going to find this bug because nothing can help me figure out that I passed the wrong value into that function. I don't really get any IntelliSense or code completion, from this IDE or any other IDE that help me figure out what I can pass in. And the challenge is that it becomes hard to use code that have written by other people unless it's really well documented. So let's just kind of poke around this JavaScript a bit and see what this particular IDE can kind of help us out with. So if I try to access array, well, I don't get any IntelliSense here because it doesn't really understand what array is. If I try to do something with result, again, I don't really know what result is going to give me because I don't know what this array.slice method is going to return. So you can start to see here, because the IDE doesn't know anything about these dynamic objects effectively, it can't help you in any way. So let's, there's other languages that kind of try to help out with this, and some of them would be maybe like Clojure, where what Clojure will do is it will try to add some parameters in the comment system called, they'll define the parameters array, and they'll give it a type here. And the problem with this approach, and the Clojure compiler can help out with this and try to validate these things, but the reality is that these things can get out of sync with the parameters you're passing in. You have to actually manually maintain them, and that the comment system is not necessarily the best place to start statically typing and describing the code that you're writing so that the IDE can pick up that information and start to help you out a little bit. So let's start to look at how TypeScript can help us out here. And the way that it does that is by providing static typing information. So we can actually tell the code, or tell the IDE and the compiler what we're expecting. So me as a developer, when I'm writing this sorted method, I might decide that I want to say that the first function here is an array, and it takes an array of anything. So any object, and it's an array. So this is static typing information, and I just put it in line, and this is what TypeScript and the IDE can use at design time to start cluing me in as to maybe some problems that are happening in my code. So let me just save this and just show you something. So nothing's changed on the right hand side. So it's still an array. This type information that we've put in here just dissolves away. It's design time only. So that's the nice thing about it. So let's look down through the code now, and I see that the IDE is actually complaining about this method sorted, and it's saying that the supplied parameters do not match. So if I look at this error message here, saying the supplied parameters do not match, the type string is missing property join from type any. And now, because we have typed the array argument and we've told it it's an array of anything, TypeScript knows to expect an array, And so when I start to access properties of the array, you'll notice now that I am getting IntelliSense. Let's try that again. So I'm getting IntelliSense here in this list, and I know what methods and properties are on this object now, because TypeScript understands that this is an array that we're dealing with. Now, when if I slice the array, I also see IntelliSense here that says that it's going to return an array of anything. So TypeScript is actually able to flow that typing information through and understand that the result that's going to be returned from this array.slice method is an array of something, anything really. Which is kind of nice, because now when I do things like result.sort, I actually get IntelliSense here. I can see all the methods that I would have on an array. I can sort it, and I can see the parameters that are expected by the sort function. And I can see here what it expects to take. So the interesting thing is that this type information, all I had to do was specify it once here, and that type information has flowed down through these variables into the sort method and actually even right back out. So we know the return type now of this function. So if I look at the help that this is showing me here, I can see that the sorted method takes an array of anything and returns an array of anything. So that's actually pretty cool, because down here now TypeScript is actually complaining that I haven't passed in the right parameters, which is great, because now I can actually fix this at design time. This code will not compile because of this problem with the sorted method. Now this, you would have had to find at runtime, and now we can actually catch these types of things while we're designing and developing the code. Let's try to go and fix this. So what I really should have done here is I really should have passed in an array, and had there been documentation available for this function and I read it, I would have known that. Or if I had looked at the implementation. Now this is a pretty simple function. If it was a much more complex function, it may not be obvious what you actually need to pass in. So this is where it gets a little bit tricky for developers new to a code base or a framework to figure out. So anyways, I figure here I should really pass in an array, since it looks like that's what it expects. So let's just do that. Now that I've passed in an array of values here, I see, okay, well, sort it. Yeah, okay, that's the red squigglies have gone away, so it must be right. Now if I save this, you'll notice over here that the JavaScript has updated itself correctly. So I'm now seeing the array being passed in through here. Let's take a look here. So now if I try to access the sorted result, let's say the first element in the array, I'm not getting any IntelliSense here, because it doesn't know what the contents of each element in the array is, because I've told it up here that it could be an array of anything. So I'd like to kind of get some IntelliSense on this. I think that would be pretty cool if I knew what each of those entities were in each of the elements in my array. So let's go fix that. Let's use a feature of TypeScript called interfaces. So let me create an interface here, call it iEntity, and let's say that it has a single property called name, which is a string value. Okay, so this interface is just a way of describing shapes, and TypeScript uses what's called structural typing, or in other words, if it walks like a duck and it quacks like a duck, then it is a duck, right? So duck typing. So in this case, anything with a name property appears to implement that interface. So I can use this iEntity interface now. Instead of saying I want an array of anything, I can say that this function expects an array of iEntity. And that's useful for a number of reasons, because as you'll see down here, we've actually caught some other problem here. Because in the past, when we said array can be an array of anything, it didn't know that X had a name property. So it just kind of allowed that code to be, this whole statement to be valid. But what we're noticing here is because now we've typed name, it knows that X is now an identity. And let's back up here a bit. So array is now an array of identity, and when the slice method operates on array, it returns another array of identity, and that kind of trickles down through the function here. The interesting part is when we get into sort. Now, sort takes a callback function that's going to be called on each element of the array, and it's going to get passed an item in that array as an x and a y parameter in that callback function. Now, TypeScript's smart enough to figure out and flow this type information through. So we can actually see here that x is actually of identity and y is also of identity. If I can get the IntelliSense to work, there we go. And the benefit of that is now that inside this function we know what the properties are on x. So I can go x dot, and I can see, oh, it's got just a single name property. Now, name is a string, and if we look at what's available on a string data type, we can see that we've got a number of functions here, and one of them is called locale compare, and you can see from this line of code here, that's actually a typo. So I can fix that, no problem. Locale compare. So it's going to do a string comparison on those two values and return whichever a value that indicates whether x is greater than y, and that fixes our problem. Now you also notice down here, now that I've said that the objects in the array are of type identity, the sorted method is complaining again that it's no longer valid because I can't actually pass in strings. I need to pass in objects that have a name property. So let's take a quick peek at what the IntelliSense is showing us here. So I can see that type of property, let's see here, identity are incompatible with the value. Now this is a object literal that we're passing in, and it's basically saying that I can't pass an array of strings in. It's expecting an array of identities because they're not compatible. So let's fix that. Okay, so let's grab a little snippet of code to avoid me typing here. Okay, you can see here that I've got my sorted function and I'm passing it an array of these object literals that have a name property. And that satisfies the type information that I've set for this argument here. And because this object literal has a name property, it basically matches the shape of this interface that I've defined up here. So the TypeScript compiler and language service is not going to complain about the value that I'm passing in here. So now I can actually save that, and if I run this, I should hopefully see the sorted results here. So that looks like it's sorted correctly to me. So close that down here. Now that we've got a little bit of typing information in here, let's take a look at how you might actually refactor this code. So I don't need this stuff anymore. So let's just save that. Let's add var name equals 1, 2, 3, 4. Okay. So I just added a local variable inside this callback function to sort. And now the way that you might normally do this is I might actually just do search and replace. So I might say that I want to replace name with entity name, because these files could be quite large. And this is really one of the few options that you have with editors that don't have static typing information available. Editors are not smart enough really on their own to understand how you want to refactor your code. So if I just do this search and replace, I'm just going to replace everything here, or replace 4 occurrences. Now you'll notice it replaced x.entityName here. Now what I really intended, I wanted to rename this name property from name to entity name, but it actually unintentionally changed entity name to name. And to avoid this, I'd have to sit here and crawl through all the lines of code, and the more code I have, the more likely it is I'm going to screw that up. So let's just undo that, and let's show you some of the power that TypeScript can enable in some of these more modern IDEs. So instead of actually using this find and replace or refactoring by find and replace, let's right-click on name here. Now I can go into refactor and I can say rename, and I'm going to change that to entity name. Okay, so what happened here now? So we've got entity name here. That got renamed. Okay, that's fine. It renamed it down inside the callback function as well, here and here, but it didn't touch this name, which is great because I didn't want it to do that. That's just a local variable. So you can see here that this is how you get safe refactoring in large code bases. This is all the type of stuff that TypeScript can kind of start to help out with and kind of help avoid you creating a big steaming pile of code. Let's just undo that for a minute. So now that we have our interface here, let's take a little bit of a deeper look at what you can use interfaces for. So I'm just going to add, let's do declare a variable here, e, and make it of type entity. So again, I'm just adding some typing information when I declare this variable, and I'm going to say equals, and now you'll notice I can't assign it to an empty object literal here because it's actually complaining that the type is this object literal is missing a property called name from type iEntity. So that's kind of cool. It just means that I need to supply a name here of something. Let's say Richard. Okay. So now that satisfies the condition, and the error indicator goes away. So that's actually pretty handy. This is what's helping you to define the object literals the way that you expect. It's pretty easy to just accidentally forget to specify a value on your object literal that you were expecting, and then only at runtime will you find that it's not there and that your code broke because that variable is undefined. And what you're seeing here is an example of contextual typing. And what TypeScript is doing is it's flowing the type into the object literal. So we define the type here, and it's flowing it into this object literal and contextually typing the contents. And since we know what's supposed to be returned, which is an iEntity, we can TypeScript can infer that this object literal needs to satisfy that the shape of that iEntity interface, and that's why if you specify a value, the property that's incorrectly named, it will automatically tell you that you're doing something wrong there. Okay, so let's add a couple things here. Let's add a price. Let's say it's a number, and let's add in stock, which is a Boolean value. And you'll notice here that again we're getting all the nice little red squigglies here, and basically what it's telling us here is that this object literal, which has a name property of string, it can't convert it to an iEntity, and that's because it's missing price, and at least it's giving you the first name of the property that's missing, but it's also missing in stock. So let's go satisfy that condition there. So let's go add price, and let's add in stock. Alright, and so that's Boolean. Oops, sorry, that's a value of true. Okay. So now it's valid. We've defined the object literal correctly, but what if in stock was optional? We can model that, so let me get rid of that. So I don't want to have to specify in stock all the time, and it's complaining now because in stock is missing. TypeScript supports optional properties on your interfaces, so I can just put a question mark in front of that now, and this now becomes valid. And if I look at the IntelliSense here, I can still see that in stock is available to me if I want to specify it, but I don't have to. Okay, if I fix that. Now, if I accidentally assign the wrong type, or I put a value on in stock that I wasn't expecting, again I get the error to say that it can't convert this object literal into this because one is not technically a Boolean value. It really has to be true or false in this particular case in order to satisfy the interface constraints. Okay, so other things that an interface can have is they can have functions. So let's just drag that over there. Let's just define that this iEntity must have a getName method that returns a string and takes no arguments, and has a setName method which takes a value and returns nothing. Now I can see down here, because these are not optional, that again, this object literal is not defined correctly. So what we need to do here is we need to define those functions. So in the interest of time, I'm just going to drag a couple functions in here. And I can see now that I've actually specified the implementation of those functions inside of this object literal. So I can see getName here, and I can see that it is a function that takes no arguments, that returns a string. And I can see that here in the syntax. So this is a lambda syntax, which is basically a short form notation for what you're seeing here. So there's the function, where it takes nothing and returns name, which is a string. And again, for setName, it is a function that takes a single value, and you can see that the value is actually inferred. The type has flowed through here because we've defined value up here as a string, and we've told it that this object literal must be an iEntity. This function must take a value that is a string. So I don't have to explicitly say that this is a string, although that's fine. I can do that. I don't need to. So it helps to minimize the spread of this typing information throughout your JavaScript. And I can also see here that it sets the name property here of the object literal to the value, which is a string that's being passed in. Now if I save that, you can see here that the interface definition, and I probably should have shown this earlier, but the interface itself dissolves away. There's nothing there. This is design time only. This is static typing. Everything else, all your code is more or less exactly the same. Nothing changes. There's still your object literal over here, and your sorted function is still defined there. So this is kind of demonstrates how you can use interfaces to model entities. You can use these to model complex data structures in your application and give you IntelliSense on those. You can generate these interfaces in your build process, or as a result of using reflection or some other technology in your back end in order to extract metadata from your data models and generate interfaces that you can use in your TypeScript files to give you that kind of rich IntelliSense of your data models. So that's actually pretty cool, because what this allows you to do is you can pretty much model everything that occurs in JavaScript's dynamic type system using these interfaces. So you can model constructor functions, you can model what happens when you index into an entity, and what type is returned when you do index into that entity. Okay, so that's pretty much kind of a high-level introduction of the type system and how you add types to your JavaScript and kind of enhance it so that you can start to get some of these benefits out of your tooling. So one thing I just wanted to quickly mention was, if you just want to play with this, you don't have Visual Studio, you don't have another editor or a plugin that supports TypeScript, you can just head over to the TypeScript website here. So you go to TypeScriptlang.org, and there is a play button here, and we can go to the TypeScript playground. And if we just, let's see here, there's a number of different examples and things that you can go through to kind of play around with this, but it looks very similar to kind of Visual Studio, where you have the JavaScript output on the right hand side, and on the left hand side you have your TypeScript. So here's where you can do var x is a string, and then you can see what happens on the right hand side. So if you want to come in, you want to start playing around with this and just learning the basic concept, this is a really good place to start. So this is actually the TypeScript itself is written in TypeScript, which is JavaScript. So it will run anywhere. You can run this this is running in Chrome, it'll run in Internet Explorer, it'll run on your phone. It runs anywhere, and that's one of the advantages of and reasons why it's been incorporated into so many different IDEs so far. Okay, so let's jump back over here and take this example a little further. So let me get rid of some of the stuff that I don't need. Don't need that anymore. Okay. All right, so we're just going back to a very simple sorted method. And so you can see we have our interface. We're still expecting that the sorted method takes that. Let me just add in a little bit of product data here. So, okay, so we got some products. And let's say I want to sort that. So var sorted products equals, let's call it sorted. Pass in the products. Okay. All right, so that should work because products is an array of these items that have a name, have a price, and they happen to have an ID. Now you'll notice that ID is not defined in the IND interface, and that's okay because these object literals implement two of the properties that are required in this interface. It satisfies the condition that these are IEnity object literals. So that's okay that we can pass those in. TypeScript's not going to complain. Now let's go and access the very first sorted product. This actually technically should be sorted products because it's giving us a list. And let's take the very first one and let's see what we get. This is interesting. So I can see that we have an in-stock property, a name property, and a price, but I can't get at this ID property. So I want to technically do something like var ID equals sorted.id, but that's not valid. Technically it is in JavaScript because those object literals that are being returned here actually do have an ID property, but TypeScript is not aware of that. So how do we fix that? We can fix this by using a feature that TypeScript adds over and above what JavaScript's capable of providing, and that's generics. So let's modify the sorted method here to say that it takes a generic type T, and let's just, now if you've used other languages like C# or Java, you're probably familiar with the concepts of generics. So basically what I'm doing here is I'm saying the sorted method is going to act on a type T. We don't know what that type is. We'll specify that later. And it's going to return an array of T. So now down here, if I do this again, you'll see, I do get ID, name, and price. Well, that's interesting. Well, what happened to my in-stock? Well, it's because I've said I'm not expecting an IEnity anymore. I'm just going to take whatever type you pass in, and I know that I'm going to return that. So the help here is saying this function sort takes a type T, and the first argument array takes an array of T, and it actually returns an array of T. And TypeScript has basically inferred the type from looking at this array of object literals here, and because each element in here has a name property, a price property, and an ID property, it has inferred that it's taking an object literal with those properties and returning an array of object literals with those properties, which is why I can now get at the ID, name, and price properties in IntelliSense. Now the interesting thing here is if we look back up, we're getting an error now inside our sort function because X could theoretically be anything. We don't know what it is. We don't know that it has a name property. We don't know why it has a name property. Now, if we want to enforce that the the entity that you can pass to this method has certain properties, we can add some constraints here. So I can say that this type T must extends entity. Okay, that's pretty cool. So that error went away. And now if I go down here, I can see that I get ID, name, and price. So I still get the IntelliSense on this, and it's still taking a type T of any that must extend this. So this object actually satisfies the iEntity interface because it does have a name and a price property. So now everything's kind of working the way that I want it to work. I'm getting the IntelliSense that I need, but there's something a little bit weird because I'm not seeing that I'm getting an in-stock property here, because theoretically, I want it to tell me that that is a valid value that I can pass back. So if I wanted to, I could type this. I could say that products is actually an iEntity, an array of iEntity. In which case now, if I go down here and I check my IntelliSense, I actually get an in-stock, a name, and a price, except I've kind of lost the ability to access the ID property. So if ID was really, expected, and you really wanted that to be able to access that, and you could add it to the entity up here. It's really up to you. So you have a number of options there. Okay, so let's up our game even more. Let's say that we wanted to be able to sort this array, but we wanted to specify the field that was used in the sort comparison. So one of the ways that you can do that with generics is let's actually modify the sorted function here to say that it's going to take a function called let's say get value of key, which now this is the callback function that's going to be passed in that argument, and let's type that callback function. So it's going to be it's going to take an argument item, which is t, and it's going to return anything. So this syntax that I'm using here is just the ECMAScript 6 lambda syntax, so it's short form. If I save this here, it's basically just a short form syntax for an inline function. So now that I've done that here, I can see down here that sorted is throwing an error because I haven't given it the callback function. Okay, so now if I do that, I'm going to use the lambda syntax again. So I'm going to say x dot name. Okay, so let's get rid of that for a minute. So I just save this and let's take a look at what this gives us. So down here you can see that the lambda syntax has been expanded into ECMAScript 5 syntax because this doesn't exist in ECMAScript 5, and this is what TypeScript by default outputs to. In the future they'll support ECMAScript 6 and it won't get translated into an inline function. But what we have here is an inline function, takes a single parameter x and then just returns x.name. So that is going to be passed into the sort method up here as get value of key. So this is actually the function down here getting passed in up here to the sorted method. So let's now use those to actually do some cool stuff here. So just to save some typing, I'm just going to drag that in here. Okay, and let's save that. So as you can see here, what we've done is we're going to get the value of x that we want to sort on, and don't forget x is an item which extends iEntity. You can see that here. right? And we're going to get the value of x, we're going to get the value of y, given the property that we've passed in. We're just going to invoke this function to figure that out. And then we're going to do a little bit of comparison logic here to figure out which one's greater than the other, and we're going to return that result. So the cool thing about this now is if I write that out, let's see here, let's write that out here. Let's take my products array. I'm just going to write that out. All right, so if I run this now, and we're sorting by name, let's run that, see what we get. I can see here that it looks like, yep, everything is sorted by name, which is great. Now if I go back here and I change this, I can say sort by price. I can rerun that. And I can see that now everything's sorted by price. Which is pretty cool. So what I've effectively done here is created a very reusable sort function that we can call using generics and specify the name of the property that we want to sort on, given any type of an array that extends identity. So this is kind of the power that generics can kind of bring to your code base. We saw a couple other things here that were interesting. The use of lambdas here. This, as I mentioned, aligns very closely with the ECMAScript 6 syntax, and I just wanted to quickly mention that TypeScript, you can kind of also think of it as a preview of ECMAScript 6. So it's going to let you use features in ECMAScript 6 that maybe you couldn't normally use because the browser base that you have to support doesn't support ECMAScript 6 yet. So by using TypeScript, you can target different versions of ECMAScript. The default is ECMAScript 5. You can target ECMAScript 3. In the future, you'll be able to target ECMAScript 6. So that's kind of the nice thing about it, is you can use the latest language features now to keep your code nice and clean and have to change less. So it's a little bit of future-proofing, basically. Okay, so before we move on, you may have been wondering, like, okay, well, this is great, but where does all this type information come from for the built-in features in JavaScript, the built-in functions and things like that? Well, TypeScript actually ships with what they call a declaration file. And so if I right-click here and say go to definition, that's going to jump me to this declaration file that effectively goes through and defines every function, every method, property in JavaScript that is supported and the various combinations of those methods. And this is something that Microsoft's gone through and done this for the entire JavaScript runtime library and the DOM, and in full precision. So there's no code in here. This is really like, these are interfaces. And if I scroll up here, you can see here, there's an interface for array, which is a generic array of type T. That could be anything. And these are all of the different functions on that array object that you can call. You can see here that there's slice, there's sort, there's splice. Splice actually has two overloads, so you can pass just the start number, or you can pass the start, the delete count, and then they have the rest parameter, which is basically a collection of parameters that just get passed in here. So if we look at that quickly, let's look at splice. So if I do array.splice, I can see that there's actually two overloads here. So I can move between the overloads and you can see the different parameters. And this is really handy if you're dealing with a library like jQuery, where there can be half dozen overloads or more for a single method. And these files here, these are kind of like what you have to remember as a developer in order to use JavaScript or any other framework for that matter. Microsoft has provided this declaration file, but there's actually a collection of these things that the open source community is creating for other open source projects. So let's just jump over here for a minute to Definitely Typed. This is a website where the community has kind of come together and created a repository of all of the different declaration files. And there's a link to the GitHub repository here. You can find this website at definitelytyped.org. And let's just jump into the GitHub repository. So this repository, there's probably, I think, over 580 different declaration files that are being maintained here. Sometimes it's the library authors themselves who are producing these. Sometimes it's the open source community. But the reality is that there's coverage for about 90% of the top JavaScript libraries here. And there's also some utilities that you can install for NPM to help in your build process to automatically download these and update these as needed. But I just wanted to quickly kind of show you this site because this is where you can come to grab files for the various frameworks that you're using. So we're talking about Angular and TypeScript tonight, so let's jump down here. Look, oh, there's AngularJS. So if we jump in here, we can see that we've got a number of different declaration files. These are the .d.ts instead of just .ts. And they're broken up into the different areas. And let's just look at the core d.ts file for Angular. And if we jump in here, let's just scroll down here. You can start to see that this is where the static type information for the Angular framework has been defined. See here, there's an example function here inside of Angular static interface that's defining the bootstrap function and the various parameters that are possible to pass to this. So simply by including those declaration files, you can get IntelliSense for those frameworks. So that really helps you, avoid spending, all your day over somewhere in the Angular help docs trying to find that, what parameters to pass to a particular, function. And the more frameworks you have, the more time you spend hanging out in the help documentation. But by including the declaration files, effectively you start to get the IntelliSense you need to avoid having to go to those to that documentation to figure out how something works, because it's just right at your fingertips, right? And I can get it here. I can see, if these declaration files have provided comments using the JS doc syntax. We also see the description of the parameters here, which is actually quite handy as well. All right, let's take a look at another feature that TypeScript adds, which are classes. So let me just clean up the code here. We don't need that anymore. Let's go and add a new class. Let's call this class point. Add two properties, number and a y, which is a number. Okay, so we've got a point class with an x and a y coordinate. Now, classes aren't actually available to you in ECMAScript 5. In order to create a class in ECMAScript 5, you effectively need to simulate that class by using function closure. So if I just save this here, what we're going to see is we're going to see that the TypeScript compiler is going to generate idiomatic JavaScript that represents the class that we want to create. Now, in ECMAScript 6, classes are going to be added, and the syntax that we're using in TypeScript here in order to define a class, that is the exact same syntax that you're going to see in ECMAScript 6. So at some point in the future, when TypeScript supports compiling to ECMAScript 6, this won't change. So if we target ECMAScript 6, the same code will appear on the right-hand side here. But if we need support for down-level browsers, we need to generate idiomatic JavaScript that represents that class. So if we're targeting ES3 or ES5, then we're going to get this type of stuff on the right-hand side here. Now, JavaScript supports prototype-based programming methodologies as well as object-oriented programming patterns. And the challenge is with the current version of ECMAScript, it's a little bit messy in order to do object-oriented programming with JavaScript. And if you read the JavaScript patterns and practices books, they'll talk about creating idiomatic JavaScript, which is the JavaScript that you would have to write in order to simulate a class. And that's what we're showing here on the right hand side, and that's what TypeScript is outputting. And what you can see here is that TypeScript is putting everything into an immediately invoked function expression here, or function closure. I can't highlight that. Let me zoom in here. So you can see this function closure here, and it's being invoked immediately here. And what that's doing is giving it the privacy that you would need in a class. It also adds a constructor function here, and then it returns that constructor function. So that's kind of the work that you need to do to create a class. And classes can also help with avoiding global scope pollution, variable hoisting from within blocks of your code. So there's other advantages to using it. It also can help you a lot with if you're coming from an object-oriented background. This just may make more sense to you than prototype-based programming. Okay, so now that we have this point, let's go create a new point object. So let's say var p equals new point, and let's assign it some values. So now when I access p here, I can see that I've got two properties here, an x and a y. So let's assign that. Okay, so I've just done the assignments. The compiler is happy, but let's take a look here, and let's make this a little bit easier to use. Now, TypeScript supports constructors, so I can add in a constructor here, and I can give it two properties here, an x, which is a number, and a y, which is a number. Now I'll need to take those values that are being passed in, and I'll need to assign them to my properties on my class. So I'll have to say this dot x equals x, and this dot y equals y. Okay. Now you see that TypeScript has updated the code that it's generating on the right hand side here. So now you can see a little bit more of what's going on here. It's assigned to the instance the x and y. It's assigned the values that we've passed into the constructor function here. So it's assigned those here to the instance, and then it's returned the constructor function. So there's nothing really unexpected going on over here, but I do notice on the left hand side that I've got a problem. And the problem is that TypeScript is saying that the supplied parameters don't match because I've now said the constructor has an x and a y. So let's just pass in some values there, and that'll save me having to initialize them explicitly there. Okay, so that cleans things up a little bit. Okay, so what else can I put in a class? I can put methods in my class. So I can declare a method here that calculates the distance. So let's just say return this dot x times this dot x plus this dot y times this dot y. Okay, so there's a method that's going to calculate the distance. I can also add static properties. So let's do static origin, which equals a new point. Let's say 0, 0. Okay, I should get rid of that. All right, and let's save this, and let's see what we get over on the right hand side here. Okay, so again, we're putting instance variables here on the instance that the constructor function is returning. We are putting functions here, so our dist function is on the prototype of the constructor function, and which is here, and we're putting statics on the constructor function itself. So this is all just the way that you do it if you're creating idiomatic JavaScript and you're trying to simulate classes. Now you can see, I mean, from a readability standpoint, obviously, what's on the left-hand side is a little bit easier to read than what's on the right-hand side. But you can start to see that this class is getting a little bit more complicated. And as we go on, you'll see kind of the benefits of why you might want to use TypeScript when you're dealing with real classes and not just demo code. So what else can we do here? We can add some, say, a private variable. So I can add, let's say, color, which is a string, and I can make it private. And if I save that, let's add an assignment here. All right. So you'll notice when I didn't have an assignment, TypeScript doesn't bother to output anything on the right-hand side in your JavaScript because there is no assignment. It's not worth outputting anything. But now if I add an assignment here and I save it, of course, then it has to do the assignment on the instance and set it to the value that I've set. Now there really are no private variables in JavaScript, but the benefit to adding this private decorator here is that outside of the class, if I try to access P, you'll notice I can just see the methods that are public by default. So I see the distance method and I see the X and the Y property. So by default, if I don't declare anything, the properties and the methods are public. In order to hide it from the developer that might be using this class in TypeScript, I need to put a private on that. And this is kind of one of those things that allows you to kind of enforce the way that you want the object to be used by others. And in the future, you'll notice on the right-hand side here that it's really not public. There's nothing that private. There's nothing that prevents a developer from accessing color. But in the future, in ECMAScript 6, I believe there's a proposal that called symbols that will effectively allow you to create hidden properties or hidden property names. And in the future, the TypeScript team is saying that that's something that they're going to consider, which is turning privates into symbols in ECMAScript 6. So let's look at something that's happening here. It's a really common pattern. We see that we've got a constructor function which takes two properties. We're then assigning those properties to the instance, which those properties are defined up here. So that's something that you see a lot of. Luckily, TypeScript provides us a shortcut here. What I can do, and these are what are called constructor annotations. So I can add a constructor annotation here called public. So I've just declared that these two things are public, and by doing that, I see that TypeScript is now complaining that there's a duplicate identifier here, that X is a duplicate identifier. And the reason it's doing that is because, let me just delete this code and it'll be evident what's happening. And if I save this, so you'll notice nothing changes on the right hand side, even though I've saved this, and I'll just get rid of that just in case. There we go. So nothing's really changed on the right-hand side. The order has changed, but that's about it. And so what TypeScript is doing here is it's actually creating the idiomatic JavaScript and injecting a couple lines of code here to do the assignments for you automatically. And because you've said that you put public in front of this, you could put private here if you wanted as well. It's not going to change anything on the right-hand side, but it will change how you access it down here. So let me change that back to public and save that. So that's a nice little shortcut. Your code's starting to get a little bit more readable. Now let's say that I I want to have some defaults because I don't want to have to always, initialize this point class. Right now, it's requiring X and Y to be passed. Now, I can change that by specifying a default value here. And the minute I do that, I no longer need to pass the values when I create a new instance of point. And you can see here, oops, let's see. All right, so you can see here now that point has, now the question mark there, it means it's optional. It has an optional X of number and an optional Y of number. And that it returns, when I create a new one, a new point. So that's pretty handy. That's kind of cool. So there's even less code to write now. And if I generate this code, what you'll see on the right-hand side is now TypeScript has injected another couple of lines of code here that automatically check to see if X or Y are undefined, and if they are, then it just sets the default values here. So it's all kind of boilerplate stuff that you don't have to write anymore. Let's take a quick look at inheritance. Let's create a new class called point 3D, and let's say that this class extends point, and let's save that. Aha! So now, if you look at the right-hand side, this is starting to get a lot less readable in terms of what I was intending to try and do. So let's dig into what's going on here. Let's see what's happened. Let's just zoom in here a little bit on the new class that it created. So it created another function closure here, and then it immediately invokes it, passing in point, which comes into this function closure as super. And then you'll notice here that we have this underbar extends point, and then it passes in super. Now, this extends is actually a function that's been added by TypeScript, and this is actually the only point that TypeScript ever injects a helper function. And this helper function is needed to help set up the prototype chain and copy all of the static properties from one constructor object here over to the other. And this is really only ever emitted if you have a derived class. In other words, over here we say extends point, and it's only ever done once. So this is all the code that it would ever add in. And then it's leveraged down here inside of the function. So the other thing that happens here is inside of the point 3D constructor function, it basically calls the base class, the constructor function on the base class, and applies all of the arguments that were passed into this particular constructor function. So that there's a whole bunch of work that had to get done here to set up the inheritance. The class inheritance here, and this is the type of stuff that you might go out and pull down some other library to help you out, maybe like prototype.js or something, and this is all handled for you at the compiler level. You don't need to take any dependencies on any third-party frameworks or libraries to help you with this. This is all just done by TypeScript at the compiler level, outputting idiomatic JavaScript and adding in one additional function for you here to help out. Now, in terms of readability, this is it's really obvious now what the benefits of using classes are if you're following an object-oriented programming paradigm in your code. Some of the other things that are useful here is, if you're modeling your data models using classes, obviously you're going to have much more terse code. Some of your data models can get quite large. The object graphs themselves can be nested, and the less code you have to write and the more readable it is, the better it's going to be long term for maintainability. So that's kind of what I really like about classes, and coming from a .NET background and C#, this makes a fair bit of sense to me and the other people on my team, and it allows us to transition, the C# language and JavaScript right now with TypeScript feel much more similar, so it's much easier for individuals on teams to jump back and forth between projects. Alright, so let's just clean up the code here a bit. Let's do that. Alright, and let's talk about one more thing, because right now if you look at this, what's actually happening here is when TypeScript generates this code on the right hand side, it's actually taking the class here and assigning it to this point. Now that's a point variable, and this is in the global scope. Obviously this is not something that we want to do in a real application. We want to protect our global scope as much as possible so that we don't pollute it. And the way that we can do that, TypeScript supports the module syntax here for creating namespaces. So I can just say utils. Let's create a namespace called utils. And okay, and let me save that, and let's just see what happens here. Again, on the right hand side here, this is just idiomatic JavaScript, and this is like the patterns that you would use in order to create namespaces. So you can see that we're creating a variable here called utils, and we have an immediately invoked function closure here, where we're passing in utils if it already exists, and if it doesn't already exist or it hasn't been defined, then we're going to create a new empty object, and that's where our function is going to be defined. So that's what's going to give us, it's what's going to allow us to protect our scope in JavaScript. So on the left-hand side, let's take a look at this. So how, we're getting an error here now because TypeScript is complaining that it cannot find the symbol point. And that makes sense now because we put it into a namespace called utils. So if we were to go and try to access that right now, and I invoke my IntelliSense, I'm not getting anything. And the reason for that is because I haven't exported the class from this module. And so I can add the export keyword here. And now if I say utils.point, now I get the point class that's been exported, and I can create new instances of that. So let's just save this here, and let's go take a look at what's happened on the right hand side a little bit deeper here. So we've got this utils variable object that's being passed in here, and what we're doing is, because we've exported the point class, it's actually doing the assignment here and putting a property on utils called point and assigning the point variable here inside of this function closure. And that's what, this is the assignment right here that's doing the that's making this class available outside of the namespace. You can see here, if I remove export on the left hand side and I save it, that's the variable that goes away. So I'll put that back, and then I can see it's come back here on this side here. Now this is kind of a simple example. These are what's called internal modules. TypeScript also supports external modules, which I'm not going to get into, but TypeScript is capable of exporting external modules in one of two formats, the common JS format and the AMD format. And I'm assuming that in the future it's going to align around whatever ECMAScript standard there is for defining modules. So right now, this is really handy if you're creating libraries for Node.js on the back end and you want to try to organize your code. This is really handy for that. You can just export these as reusable common JS modules and then import them into your Node projects. Okay, so that's kind of the 10,000 foot view of TypeScript, and hopefully by now you can kind of see how this would benefit you on really large projects where you're trying to write less code, because the less code you write, the less bugs you write, and it's kind of that simple. But you're also getting a lot of help from the TypeScript compiler to make sure that you're not doing things wrong in your code that you're not going to notice until runtime. So to me, that's kind of the major benefit. Secondary benefits are IntelliSense, getting good code completion, and not having to jump in and out of documentation systems to figure out how these third-party frameworks work all the time. There's a lot of benefit that you can gain just by kind of taking the bits and pieces from TypeScript that can help you now. You don't have to use all of it. You don't have to convert everything to TypeScript. You could just import your JavaScript, add a little bit of typing information, see if it compiles, and see what other errors it catches. And I've seen that work really effectively, which is literally just dragging all your existing JavaScript into TypeScript, adding types in certain places, and making sure that everything compiles. That's almost like your first unit test. Will it compile? Let's look at something that's a little bit more exciting than these simple demos. What I've done is I've gone out and I'm sure everybody's familiar with the To-Do MVC site. This is really a reference application that has been written in a number of different frameworks so that you can compare, how they work. And there's been a little bit of work by a few people that have actually converted the To-Do MVC Angular project into a TypeScript application. So what I wanted to do is just pop those two projects open here, and let's just minimize that, and let's open up the other one here, which is the TypeScript version. And effectively, these are there's a couple little differences in them, and I'll include a link at the end of the slides here so that you can go check these out on your own. But effectively, this is just an Angular application, and it's even hard to tell the difference between them if you're just looking at the index.html page. So I can see here that I've got a to-do controller that I've hooked into this section here. I've got some methods on that controller called add to do. So if you look on this side, you're not going to see to do controller because they're using the Angular router to hook up the controller based on navigation. So, but you will see things like to do controller add to do. So they're still binding to methods. So you're not going to focus here. This isn't really the exciting part. Okay, let's look at something more interesting, which is the controller. So I'm going to, on the left here, open up the JavaScript version of the controller, and on the right-hand side, I'm going to open up the TypeScript version of the controller. First of all, let's kind of take a high-level look at some of the things that are happening inside of the controller. So we've got obviously a to-do MVC module here that's been defined globally, and we're going to create a new controller, and we're going to pass it a function here called to-do controller with a number of parameters that are going to get injected here. And one of these here, so we've got some filters, these are all Angular objects, and we've got a to-do storage service that's going to get injected, and that's the service that this application uses to read and write to-do items to local storage. So a couple other things that we're doing here is we assign a list of to-dos by calling to-do storage.get. So we're calling data service, and we're retrieving those. We're putting that on the scope. We have a variable to hold a new to-do item, which defaults initially to blank. We have a remaining count of to-dos to work on, and it's actually using a filter to sort the list of to-dos that we got back from the service, and it's looking for ones that have not been completed yet, and it's retrieving the length of that result into remaining count. So doing a little bit of work there to set that up. What else is interesting in here? We've got a couple of watches set on the path, and another watch here on the remaining count, and those are going to get executed when these expressions change. And so let's take a look. There's a couple other methods here called add to do, which is a function which goes and grabs the latest to-do item that you've added and basically pushes it onto the to-do list and then writes it to storage. And then there's a number of other helper methods which I'm not going to go into too much. You can look at that on your own if you like. So on the right-hand side here, this is the TypeScript equivalent. We can see here that we've decided to use some namespacing called to-do MVC. So that's going to create, namespace to protect our global scope from all of these types that we're defining in these classes. And you can see here that we've got a couple interfaces. So we've got an interface of iToDo and another interface of iStatusFilter. And if we look at iToDo, I can see it has a title and a completed property, and iStatusFilter has a completed property here. So we'll see where those are used down here. We've also got a class called ToDoController. And so far, we've just set up a couple interfaces, and now we're defining the class of that's going to represent the controller. And it has some public properties on it here. So it's got a collection of to-dos, which is an array of iToDo. So that's an array of this interface. So every object in there must implement this interface. We've got the original to-do, which is just a single to-do. We've got a new to-do, which is just a string and some other variables here. And you can see here that we also have a constructor function. And this constructor function, we're passing in scope, the root parameters, we're passing in and to-do storage. So we're passing in a few things here, not quite the same as the stuff that was getting passed into the JavaScript controller. But nonetheless, these are what Angular is going to automatically new up these things using dependency injection and pass us the objects to our constructor whenever we create a new to-do controller. And there's a little bit of magic happening here behind the scenes that may not be immediately obvious, and that is that this ng-inject slug that has been added to the code, this is actually used by a step in this project's build process. I believe it's Uglify.js that's looking at this and is going to inject the syntax needed to make this code safe for minification. Now, effectively what this does is in the build process, it's going to add a property called $inject, and it's going to set it to an array of values like scope, root params, and the what's it called? The to-do service, storage, and Angular, when it is going to automatically look for this this property on this object, and it's going to understand that when it calls the constructor function to go and new up instances of these objects and pass them in, or locate the correct dependencies and pass them in. But we don't have to do anything like that here because that's going to be done for us in the build process. That also avoids us having to try to keep these parameters here, like scope, in sync with the parameters that we're passing to the constructor. So that's the nice thing about using that. And I'll show, I'll add a link into the notes that talks more about how you can use ng-inject to kind of work around having to add $inject to your controllers. So what we can see here is where there's a constructor annotation that's been added to just make this root params private. But the other interesting thing is we've actually we're scoping these. We're assigning a data type to the scope variable, and these are the type annotations. And these type annotations here, and I showed you earlier from Definitely Typed, you can download these typings, and let's pull one open here. Let's pull open the core typings, and these have just been added into a typings folder here in the project in an AngularJS folder, and I want to go take a look at this one, which is the AngularD.ts file. So let's do that, AngularD.ts, and let's just search for iScope. Okay, here it is, sorry. So iScope extends iRoot scope service, and we can go to the definition of that one. And now I can see here that it's basically an interface, iRoot scope service, and it has all of these different methods that are available on the root scope that I have access to. So by typing, let's go back to the controller, by typing the scope to say that this is ng iScope, now when I use the scope argument here, I actually get to see all of the properties and methods and functionality that's available on the scope. So that's actually pretty cool. And if I actually pick one of those, so let's just use on as an example, I'm actually getting now IntelliSense that is giving me a description of this method, and it's even describing the very first parameter. So as I go through the parameters, it's saying name is a string, and name is the event name to listen on. So that's actually, pretty handy. I don't have to try to remember, all of the different functions that are available to me on scope that Angular offers. So that's pretty powerful. So there's a couple other interesting things. TypeScript supports getters and setters here, and in which case if we create a getter and setter, this is really equivalent to other, like a computed value. So if you're familiar with like Knockout.js and their computed observables, this is effectively accomplishing the same thing, because Angular is going to automatically check these getters and setters whenever any of these values change. So you can kind of consider these like computed values. So there's one here for completed count and remaining count, and it's really just accessing the to-dos collection and reducing it and passing in a callback function using the lambda syntax here. Again, TypeScript is allowing you to use this lambda syntax, and it's just going to do a calculation and return the value to determine if the to-do item is actually completed. So there's a couple of those here. There's a couple public getters, so read-only getters. We have a save method, which is called, and then we have the add to-do method. So you can just see that the save method is actually a private method. So obviously we want to only allow other functions within this class, other methods, to call save. We don't want to expose that externally and let anyone who's using this class call that. So add to do here, we can see that it's actually doing something very similar to what the JavaScript function was doing, in that it just goes and grabs the to-do, pushes it onto the collection of to-dos, and then saves it, and then just resets the to-do. The other thing it doesn't have to do anymore is bother with the remaining count and updating that, because all of that functionality to calculate that value is really just been kind of refactored into a property getter, which is kind of cool. So at a high level, that's kind of the controller. Let's take a quick look, because we can convert everything over to TypeScript. And if we just look at one of the directives here, let's look at the to-do escape directive. Really hardly any difference between these, other than the fact that we are actually scoping, assigning data types to these arguments here on this lambda function here that we're returning. And interesting one here is the element, because we're actually getting a jQuery element. So that's actually a typo, shouldn't be there. if we look at elements dot, and I do dot, now we're getting all the IntelliSense for this jQuery object, and I can see that in this list here. So this is actually really handy now that I can start to kind of dig in, and I can see the bind syntax. And with bind, I actually see that there's 5 different overloads of this function, and I can see all the different combinations of that are available to me, and it's even helping me out again with describing what each of the parameters is. And again, it's getting that because we have included a jQuery d.ts file into the project, and that's what's defining all of the functions. So if we go and we take a look at the bind function, which we were just playing around with, I can see all the different function overloads, all the different declarations for the different combinations of the bind function here. So that's pretty cool. So if you're familiar with directives, there's really nothing surprising going on here. This really is the exact same code in TypeScript. The difference is that you have this because we've typed these arguments to the function. It just makes our life a little bit easier, especially if this was a really complicated directive and I had a lot more code that I was having to manage and maintain here. The other big difference is just the use of lambda functions here instead of inline functions or anonymous functions. So this, it's up to you whether you believe that's more readable or not, but if you want to use them, they're there. So lastly, let's just go look at the to-do storage service. And let's go pull that open here. Where is that? There it is. Okay, breakpoint here. All right. So the big difference that we have here is that we have in JavaScript, we're just registering a factory, passing it in this function here that's going to act as our singleton data storage service. And it's got 2 properties here, a get and a put, and we're just using this syntax here to return an object with the functionality that we want on it. Whereas over in the TypeScript world, we've got our same module to namespace everything. We're exporting a class called to-do storage, which has a constructor which takes a window object for the Windows service. One of the differences that you can see also is that we've got the getters, a get and a put here. We also have a get and a put over on this side, except there's type information. So this get returns a collection, an array of I-to-do objects, whereas the put accepts a collection of I-to-do objects, and then it just writes it to local storage. So nothing really exciting there. You might be wondering where is this to-do storage service actually being registered? And to answer that question, let's go look at to-do MVC TS. So there's a couple things going on here. This is just this is going to get compiled down to a JavaScript file and included. So it's just a slightly different way of registering everything here. So we're grabbing the to-do MVC module. It has a dependency on ng route. Now you can see that we're registering a service here, and we're passing in the TypeScript class. Because we're using service, Angular knows to only new up this class once. So this is effectively registering this class as a singleton. So anytime we inject the to-do storage service, we're going to get a singleton back. We're also in this config step here, we're injecting the root provider, and we're configuring it to hook up the controllers. So this is where we're saying the controller is the to-do MVC to-do controller. And we're using the controller as syntax. This just makes it a little bit easier to kind of understand what's binding to what when we look at our index.html, but it also has the added benefit, if we jump back to the controller here, is that I can just, instead of having to always have to be assigning everything to the scope, I'm just creating my properties here on the class itself. So I've got a couple of properties, getters and setters, and I've got some methods. These are all just being added to the class instance. I don't always have to be adding them to the scope. So let's jump back to this, and yeah, so this is basically just setting up the routes. So, pretty simple example, obviously, but it does give you a good starting point to kind of learn. If let's say you want to use TypeScript in your Angular application, this kind of shows you all the little tricks to get there. And beyond that, it's actually really quite simple. You can back out of TypeScript at any point that you want. You can kind of incorporate it just to get code completion. You could use classes. You don't have to use classes. You can this is perfectly valid TypeScript. So you can still write it you can still write your Angular applications the way that you're used to. And if you get nothing else out of using TypeScript, you might just get IntelliSense and code completion. Now there's actually one last thing that I wanted to show, which isn't quite obvious. And you might be wondering, well, okay, do I just have to drop these declaration files into my project, or how do I link these in? And because we're using Visual Studio in this demo, I don't actually have to do anything explicitly in order to reference these files, because the IDE itself automatically scans the project, and any of these files that are included in the project, it will just assume that you want to use them, so it just automatically kind of links them in. Now if you were using some other IDE, you'd probably need to add a reference to that file if you wanted to use things like, say, from Angular here. So ng scope, and the way that you could accomplish that is just by adding, let's see, I drag this in here. The syntax for how you would add in a reference is you just put 3 forward slashes and then reference path, and then the path to the d.ts file. If you add that, then you'll be able to use the typings that are supplied inside of that declaration file. If you have a number of files, you could actually create a single TypeScript file, drag all of the references in there, and then just reference that single file from all of your pages. So that's, if you're in a more complex project, that's probably much more maintainable. Usually you call it something like all.ts or all.d.ts. You can drag these references into that and then just include here, instead of angular.d.ts, it would just be all.d.ts. And so that's one approach to make your life a little bit simpler. Okay, so that's pretty much it. Hopefully you kind of have a little bit of insight into how you might be able to use TypeScript in some of your projects. It really is complementary to the way that to Angular or any other open source project, and regardless of how you program, whether you prefer prototype based programming versus more classical object oriented. Okay, so that's it for my presentation. I hope that I was able to show you how TypeScript can help building large scale JavaScript applications. It really is a technology that you can use with pretty much any JavaScript framework that you might be using today to just increase productivity, reduce bug counts. It's going to give you, if you spend the time to learn it, you'll definitely appreciate the productivity and quality improvement that it's going to add to your projects. I also wanted to mention that if you think that you'd like to work on technologies like this on Angular with TypeScript on large scale, complex applications, come work for us. We're currently hiring for front-end web engineers, and we've got some really interesting projects that we're working on. So again, just you can either scan this code, go to that URL, and check out the job postings that we have available. And thanks for watching.